for this problem, we're going to graph this system of linear inequalities. To do this problem, we'll graph each linear inequality individually. So let's start by graphing the first one. So we'll change it to have an equal sign, and we'll make an xy table to find points on this graph. If x is 0 in this equation, then y would be positive 2. If y is 0 in this equation, then x would be negative 1. So we have the 2 points 0, 2 and negative 1, 0. If I draw a line connecting those, I need the line to be a dotted line because we have a strict inequality. So the dotted line looks something like this. Now let's graph the other line. The other line is x minus 3y is equal to 9. And if I make an xy table here, I can also choose some x values if I'd like to. If I choose x to be 0, then y will be negative 3. If I choose x to be 3, then y will be negative 2. And if I graph these 2 points, 0, negative 3 is here. 3, negative 2 is right here. And again, when I graph this line, it has to be a dotted line because we have a strict inequality. So let's go ahead and graph that dotted line, and there's that dotted line. Now, we have to determine which way to shade on these linear inequalities. So let's choose a test point for both equations and test it. If I choose 0, 0 for my test point for both equations, I will test it with an inequality. So if I go 2 times 0 minus 0, is that greater than negative 2 for our first equation? If we calculate that, we get 0 is greater than negative 2. And that is a true statement. So for my first linear equation, I need to shade on the side that my test point was on. So I'm going to shade in that direction. Now for the second equation, I'm going to use the same test point. So I'm going to have 0 minus 3 times 0 is less than 9. And I want to answer that question. Is that a true statement or is it not? If I simplify this, I get 0 is less than 9. And yes, that is a true statement, so my test point is a solution. So I need to shade this dotted line in that direction. But since it's a system, we have to satisfy both equations at the same time, and that would be where the shadings overlap each other, which would be in between these two lines. The last thing we need to do for this problem is to find the point of intersection. And the point of intersection is found by solving the original system with equal signs. So if we replace the inequalities with equal signs and solve that system, we would find this point to be negative 3, negative 4.